Okay, this is Unit 5, Moles and Stoichiometry, Lesson 2. In our last lesson, we finished up with learning how to calculate the percent composition of a compound. And in this lesson, we're just going to focus on a special type of percent composition involving what's called a hydrated crystal. And as I explained to you in the last lesson, a hydrated crystal is something that contains water. So a special type of percent composition is hydrates. So a hydrate is a crystalline compound in which ions are attracted to one or more water molecules. For example, we have sodium carbonate, decahydrate. So sodium is the Na, carbonate is your polyatomic ion, and we have 10, and the prefix for 10 is deca, and waters, so this refers to hydrate. I'm just going to write the name of it there so you know what it is. Sodium carbonate, decahydrate. Notice how water molecules are built into the chemical formula. Substances without water built into the formula are called anhydrates. And that's due to that prefix an. Hydrate is with water, anhydrate is without water. So we're going to be working with hydrates in this lesson. So what is the percentage by mass of water in sodium carbonate crystals? Well, when we start problem solving, we have a format that we need to use, and that format is given, find, formula, solve. So we're going to write down what we're given, we're going to write down what we need to find, we're going to write down a formula, and then we're going to substitute. So it says, what is the percentage by mass of water in sodium carbonate crystals? Well, the only thing that we're given is the formula. So here is our given right here, our formula. What do we need to find? Well, we have to find the percent water. That's our question mark. That's what we don't need. We don't know. Our formula that we're going to be using is down here. This is found in Table T. Percent composition by mass equals part over whole times 100. So we need to solve. But in order to solve, the first thing we need to do is we need to know the mass of the hydrate. And we're going to calculate that the same way that we did in the last lesson. You see how many atoms of each element you have, you multiply it by its mass, and you get the total mass of the compound. So sodium has a mass of 22.98977, which gives us a total of 45.97954. Carbon, we have 1, 12.011. Oxygen, we have 3 times 15.9994, which gives us a total of 47.992. So I'm going to do water as a whole. I'm not going to separate it because there's two reasons. One, they want the percent of water in the entire compound. So when we're looking at the compound, Na2CO3.10 H2O. My part is the 10 waters. My whole is the entire thing. So I want to try to keep my waters together since that's my part. Let's look at one water over here to the left. We have H, so we have 2 times 1.00794, and we have O, which is 1 times 15.9994. So when I do, this is going to give me, I don't know, 2.0158, something like that, plus the 15.9994. The mass of one water is 18.01528. That equals 1 H2O. So that's the value that I'm going to put over here, the 18.01528. And then I have 10 of them. So that's going to give me 180.1528. So that is my part right there. This is my part. So let's add the whole thing up. 45 and change plus 12 and change plus 47 and change plus 180 and change. And I get a total mass of 286.14164. Now, what I notice is I don't have to do sig figs, but I don't want us to forget about them when we add. This has the least number of decimal places, so it would be to 3 decimal places. So I'm going to look to the right, and that's greater than 5, so I'm going to be working with 286.142. So that's the first part. I needed the mass. This is my whole. Now I can take that and use it in the formula. So my mass of my part is going to be 180.1528 over the mass of my whole, 286.142 times 100. So numerator divided by denominator times 100. And normally we represent percent to, I would just go percent comp to the tenths place. So when I do this out, I get 62.95. So if I go to the tenths place, that's going to be 63.0% H2O, because that's what they were looking for. So I'm doing the same thing that I did in the last lesson, part over whole times 100, but I'm not finding the percent comp of one element, I'm finding the percent comp of the water. Let's do another one. What is the percent mass of water in BaCl2.2H2O? So I'm given BaCl2.2H2O, and I have to find the percent of H2O. I don't know that. I have formula, percent comp equals, I'm going to put part over whole, P over W, times 100, and that's fine. I know what that means. So the first thing that I need to do is I need to find out what I've got over here. I have 1 Ba, and I have 2 Cls, and I have 2 waters. So Ba is 137.33, and Cl is 35.453, and we established that one water was 18.01528. So this is simply 137.33. 2 times the chlorine gives me 70.906, and 2 times the water gives me 36.0304. This is my part, and my whole, I'm going to add all three of these up, is 244.664. And I can see that this has got 2 decimal places, so we only want 2 decimal places. So it's really 244.66. This is going to be my whole. So I've got percent comp equals 36.0304 divided by 244.66 times 100. And I get 14.75, and we want that to the tenths place, so that's 14.8% water. Okay. Here's an unusual question. Well, not unusual, but it's time consuming. Which species contains the greatest percent by mass of hydrogen? So we are given 4 different compounds. They want the percent, the greatest percent of H. We don't know what that is. Our formula is what we've just been talking about. Percent comp equals part over whole times 100. And we have to solve for each of these. This is a typo. This should not be, I just realized that, this should not be the greatest percent of hydrogen, because only one of them contains hydrogen. This should be the greatest percent by mass of oxygen. So change that in your note packet. So greatest percent of O. There we go. All right. So number 1, we've got C. We've got one of them, so that's 12.011, and we have oxygen 2 times 15.9994. So that's going to give me 31.9988. And this is just 1, so it's 12.011. When I add those up, I need the sum. I get 44.0098. All right, so let's label. This is my P, this is my W. So I've got percent comp equals 31.9988 over 44.0098 times 100. And I'm going to wind up getting 72.7%. Should check my math on this, by the way. All right, let's do H2O. We have water, so H, I'm going to go back to the green so the problem solving's in one color and the work is in another. So H, we have 2 times 1.00794, and O, we've got 15.9994. So 2 H's is going to give me 2.01588. plus 15.9994. The sum of that is 18.01528, which should sound familiar because we just did one water molecule. This is my part, this is my whole. So percent C equals 15.9994 over 18.01528 times 100. When I do the math on that, I get 18.8%. So here's our first percent. So right now, water's got the greatest percent of oxygen. 88, not 18, 88.8%. All right, moving on to NO2. We've got one nitrogen, so that's 14.0067, and we've got two oxygens, 15.9994, so 14.0067, and two oxygens gives us a total of 31.9988. So we need the sum on that, 46.0055, 46.0055. Let's label my part and my whole. So we've got percent C equals 31.9988 over 46.0055 times 100. And when we do the math on that, we get 78.3%. So oxygen in the water is still winning. And our last one, we've got 1 mg, which is going to be 24.305, and we have one oxygen, 15.9994. Our sum on that's 40.3044. Here's my part, here's my whole. So percent comp equals my part, 15.9994, over my whole, 40.3044 times 100. And when I do that, I get 40%. So my overall winner is going to be H2O equal to 88.8%. Okay. And that is it for this lesson. Have a great day.